Don't forget to subscribe and ring that bell.
Hey there. Hey, fella. Come on over here. Don't be shy. Let's do a little bit of calculus. So, you don't know how to do some. Well, it's good you're here because I know how to do some. All right. And today, that sum is going to be free response question number 4 from the practice AP Calculus AB 2014 exam. All right. Oh boy. Yeah, we don't get a calculator. But you know what? We're smart. And these problems without calculators, they tend to be a little bit more easy in terms of the algebra behind them. Well, that's because we don't get a calculator. Let's start. Oh, I'm feeling right at ease already because number 4 gives us a graph. I love tables and charts and graphs. Oh my, I love them. Number 4 reads, the continuous function f is defined on the interval from -5 to 8 inclusive. The graph of f, which consists of 4 line segments, is shown in the figure above. Let g be the function given by g of x equals 2x plus the integral from -2 to x of f of t dt. Find g of 0, and then find g of -5. All right, let's start one at a time. G of 0, that'll be in green. So what I need to do, g of 0 means I'm just going to throw a 0 in for every x. So I have 2 times x, which is 0, plus the integral from -2 to x, which is also going to be 0, of f of t dt. All right, well, integrals are the same thing as area under the curve. And this should not be any surprise that I want the area under the curve from -2 to 0. So let's pop on up here. And -2 on the x is right here. This is -2. And this is 0 right here. Okay, so I want the area under the curve of this little bad boy right there. Now, I could, okay, I could do the area of a trapezoid, and many of you will. I just like rectangles and triangles. I don't know why, but I like doing that. So let's break this up into a triangle, which looks like it's this triangle here is 2 by 1, and the area of that is 1/2 base times height. So that area is going to be 1. The area of the red triangle is 1. Okay. Now I have this rectangle on the bottom, which I'll outline in blue, and that rectangle is 2 by 1, and that's just length times height, base times width, whatever, and that's 2. Okay, so this area is going to be 2 right there. All right, so if I add those together, my 1 plus my 2, that covers the area. That's 3 plus 2 times 0 is 0. So g of 0 is going to be 3. All right, that was pretty simple. That was pretty simple. Now, my friend, all right, let's do something else. Orange. Let's do g of -5 in orange. So g of -5. Okay, I'm still going to throw in, for my x's here and there, I'm still going to throw in a -5. So it's 2 times -5 plus the integral from -2 to -5 of f of t dt. Now, if you know anything about your rules for integration and integrals and bounds, notice that my lower bound of -2 is actually a larger value than my upper bound of -5. So right off the bat, okay, we can multiply this. Okay, we get -10 here. Plus, I'm going to flip those bounds. Okay, -5 to -2. All right, of f of t dt. But anytime I flip those bounds, I need to negate my value. So I can say plus a negative, or I could just subtract it. Okay, either way, you're fine. We're good to go. Let's find that area under the curve from -5 to -2. Let's go right back up here. Okay, I'm going to erase some of this here. All right, let's go. So -5 is right here on the x-axis, and -2 is right here. So I have two triangles, really. Keep in mind that when I take integration, anything above the x-axis is considered positive. So this will be a positive, okay, area right here. Okay, and anything below the x-axis will be negative. So when I calculate this area, that number needs to be negative. All right, so let's go ahead and do that right now. My triangle that's standing up here, it looks like it's 1 by 2. So it's 1/2 base times height. That's 1. So that's a positive 1. So we have a positive 1 here. The area of the larger triangle that's kind of pointing down, okay, that looks like it's 5 by 2. So it's 1/2 2 times 5. Well, that's 5. But since that's below the x-axis, that's considered negative. All right, here's a quick point here. If I wanted my 1 and my 5 to be positive, if I wanted both those areas to be considered positive, okay, let's look at our integral here. We would have thrown absolute value bars there. Okay, that's the difference between displacement and total distance. Okay, we don't have that in this problem. That was just a quick little review nugget for you. So we are going to, let me extend this a little bit. Extendo, there we go. We have our -10 here. We're going to subtract our area, which was a positive 1 and a -5. Okay, this is a -4. -10 minus a -4. Whenever I subtract a negative, it's like a big old fat plus. So I should end up with -6, and that is g of -5. It's -6. All right. So that first problem, yeah, I lied. Did I lie? Did I lie? No, that's good. Oh, Lord Almighty. Let me go back here. 2, that's 4 on the x-axis. It's 2 by 5. No, that's right. Why did I think this was a 3? 1, 2, 3, 4. I did lie. I got stuck with this. This distance is 4. Oh, man. That's 4, which means this is 4, which means this is -4. Man, it didn't look right. I had a feel that it wasn't right. Maybe you caught that earlier. So if this is 4, this would be a 3. Okay, and that would give me a -7, not a -6. Whoo! You know, if you caught that earlier before I finished that, good for you. All right? But I'm going fast, and I'm ripping through this quick, and when you go fast, you make mistakes. The answer, g of -5, is -7. Boom. Okay, let's shake off that rust from 4A. Ooh, man, we almost made a boo-boo. B says, find g prime of x in terms of f, and then for each of g double prime of 4 and g double prime of -2. Okay, find the value or state that it does not exist. Okay, so we're going to pull in the derivative and the second derivative here. All right, so let me go here, let me go here. Yeah. So first thing, let's answer the first request, g prime. They want that in terms of f, which means f will be in the answer. Okay, we were given initially g of x, which was 2x plus the integration from 0 to x of f of t dt. All right, so I need to find the derivative of this. All right, and if I take the derivative of one side, that'll give me g prime of x, which is what I'm looking for. I just take the derivative of my other side. Now, keep in mind, okay, the derivative of 2x, well, that's just 2 plus. Anytime I take the derivative of an integral, okay, it cancels. The dummy variable goes bye-bye. And whatever is up here just goes in for the variable down here. So I'm really going to end up with f of x. So the derivative of g of x is 2 plus f of x. This is what we just answered right here. Good. Now, okay, now let's take a look at the second part of this. We need to find g double prime of 4 and the second derivative, or double prime, of g at negative 2. Now, what I know is if I have the first derivative, okay, the second derivative, well, that's really just the slope of the first derivative, isn't it? It is. And since we have a graph, that's what we're going to look at. In order to find the second derivative, we just want the slope of the first derivative. And if g prime is, okay, if we look over here, okay, this arrow thing here, g prime is really just 2 plus f of x. So I'm really just looking at the slope of 2 plus f of x. And that's good because the graph is f. Now, anytime I add 2, okay, let's go right here. Anytime I add 2 to a graph outside of the function, okay, let me minimize this little timer here. If I add 2, I'm looking at the bottom right of my screen here, this right here. If I add 2 to a function, all that's doing is really moving the whole function up 2. So if I do this, that's what I highlighted is my original function. If I move that up 2, 1, 2, okay, now what I have right there, that's the graph. I guess I should do this in purple, of 2 plus f of x, okay? Nothing really changes except it literally moves up 2. So let's find the slope at 4 and the slope at negative 2. All right, let's start with 4, okay? So the slope at 4. Okay, 4 is 1, 2, 3, 4, right here, this point right here. All I got to do is find the slope of this line, all right? Well, okay, let's say I go from this point, 2, 3, to this point, 8, negative 3. Now, you may be saying to yourself, like, wait, I thought we weren't using the black line. I thought we were using the purple highlight. The slopes are the same there. They're parallel. The slopes are the same. So it's just a change in y over change in x. All right? So I'm going to go from negative 3 minus 3, that's my change in y, over 8 minus 2, that's my change in x. Negative 6 over 6, so that's really negative 1. G of 4 is negative 1 because that's the slope at x equals 4. Now let's look at my second thing, the slope at negative 2. Negative 2 is right here. Oh, friends. Oh, friends. Look at the problem, how it says find the values or state that it does not exist. D-N-E, does not exist. How come? My friends, this is a corner, and we cannot take the slope or the derivative, which is slope, at a point if it's a corner, a cusp, or a vertical tangent line. Those are the 3 places, corner, cusp, vertical tangent line, that if you have a continuous graph, you still can't take the derivative or get the slope there. And we have one at x equals negative 2, a corner. It does not exist. So let me bring this back up, this little timer dude, and let's continue on to part C. All right, 4C. On what intervals, if any, is the graph of G concave down? Give your reason for the answer. This is not that difficult of a problem at all. Let's first state the obvious. If it's concave down, that means my second derivative is less than 0, or it's negative. Okay? And the second derivative, okay, of g, well, that's just the slope of the first derivative of g. Okay? And if you were here for number 4, part B, the last question we just did, okay, part B of the same number, 4, we said that g is really 2 plus f of x. So really, I'm just finding the slope of 2 plus f of x. And because these are all lines, okay, it doesn't matter if I move the whole graph of f up 2, which is what this is telling me to do, okay, the slopes are still the same because they're lines, okay, they'll be parallel lines, right? In case you missed it, the graph that we have here in black, that's considered like our f, or f of x. What I'm going to do here now is I'm going to show you what the graph of 2 plus f of x would look like. Well, I take this whole graph and I literally move it up 2. 1, 2. This is what the graph of 2 plus f of x would look like. But I'm still going to look at f. How come? Because in terms of slopes, all these lines are parallel and all the slopes will be the same at the same x value, meaning the slope of this point will be the same as the slope of this point. The slope of this point in between will be the same as the slope of this point, and so forth. The slope here will be the same as the slope here. It don't matter. Okay? No. Go. God, what? Let's go here. Here. There we go. Wow. I had a breakdown right there for a second. All right. So where's the graph concave down? Basically, in order to find where g double prime is negative, I need to figure out where the slope of this is negative. So anytime I have a negative slope, all right, and that's easy, okay? From here to here, it's a negative slope because it's going downward. And here to here, it's a negative slope. So I'm going to say from negative 2 on the x, oh, boy. Negative 2 is right here on the x. I almost brought it down here. Negative 2 to 0 on the x. It's one of my intervals. And from 2 to 8. Okay, we also have a negative slope. So as I write that, from negative 2 to 0, and from 2 to 8. But they say, give your reason. Okay. And the writing, that you can't avoid it, people. G double prime of x. Ooh, which has a C in it, which is the slope or derivative of g prime of x. I'm going to put in parentheses, which is 2 plus f of x. Has a negative value in these intervals. Okay, so it's a negative value in these intervals. In fact, we could say has a negative, let's not do that. We say negative, instead of value, we should really say a negative slope, because if the slope's negative for the first derivative, the value of the second derivative is negative, okay? The second derivative of g, which is a slope or derivative of the first derivative of g, 2 plus f of x, it has a negative slope in these intervals. So if you want to go further, therefore, 3 dots, it's concave down. And you could have written that a million different ways. I always say that with any explanation. And to be honest with you, my explanation here isn't necessarily the best, but it's valid. And it works. Many of you could probably put in the comments a better explanation, and it would be good. Some of you probably put a worse explanation. But as long as you have an explanation that details your reason for your answer, you are good to go. We are done with 4C. All right, 4D. This seems like it's a crazy type of problem, but really it's not. Okay? The function h is given by h of x which is g of x cubed plus 1. So find h prime of 1 and show the work that leads to your answer. All right, it's pretty much all algebra until one point where you refer to the graph. Okay. In order to find h prime of 1, let's first find h prime of x. If h of x is g of x cubed plus 1, okay, and I want the derivative of this, h prime of x is, well, I got to take the derivative of this side. Chain rule. I start with taking the derivative of the outside first. The inside stays the same. Then I multiply that times the derivative of the inside, which is just 3x squared. Now, what we got to recall is that in the previous problem, all right, C or B, we said that g prime of x is really 2 plus f of x, okay? So I'm going to substitute. Yeah, I'm going to substitute that in, all right? So anywhere I see a g prime of x, okay, g prime of x, I'm going to put this in for it, all right? So in a nutshell, if I want g prime of x cubed plus 1, that's going to be 2 plus f of x cubed plus 1. All right? Let's go ahead and make that substitution right now. And for this, 2 plus f of x cubed plus 1 times 3x squared. I want this at a value of x equals 1. That's what they tell me right in the problem. So let's go ahead and put in a 1 here and do the math. 2 plus f of 1 cubed plus 1 times 3 times 1 squared. All right, let's do what we can here. 2 plus, okay, 1 cubed is 1 plus 1. That's really f of 2 times 3 times 1 squared, so that's just 3. Right? The only thing I need to find is f of 2. And this is the one thing I go up to the graph for. This graph is the function of f. When x is 2, my y is 3. It actually gives me that coordinate. F of 2 is 3. All right? Now, keep in mind, I didn't write this down. If I'm looking here, I'm going to do PEMDAS. I'm going to multiply first before I add. But this whole thing needs to be multiplied by 3x squared, which means this whole thing needs to be done together, which means this whole thing, which means I need to do this part first, all right? Which means we said f of 2 was 3. Did we not? We did. So 2 plus 3 first is 5. Then I'm going to multiply that by my 3. I get my 15. That's my answer. What was that, h prime of 1? That's h prime of 1. And we are done. Okay? A little shaky. You know, we got off to, we doubted ourselves at a time or two. Well, we didn't really doubt ourselves. Just something didn't feel right. Okay? And you got to go back, and checking your work is important, especially if something feels off. All right? But if you don't have a calculator, it's typically the fast algebra, the fast looking at something, it's where you make a mistake. It's not typically in the math you do. It's in going quickly. Okay, it's not the concept. It's the simple math, the simple reading, all right? Calm, patience, do your work. No reason you ain't getting a 5 on this. We'll see you. Oh, like, comment, ring the bell, you know, throw something down there. I don't know. Your favorite football team. Whatever. I don't care. Should be math related. But I'll see you. Bye-bye.
Don't forget to subscribe and ring that bell.